details here is coming from blockchain. He's an amazing developer himself, and he's introducing you through blockchain. And I'll let Abhijeet do the rest of talking. And over to you, Abhijeet.
Yeah, sure. Thanks, So let me just introduce myself again. I'm Abhijeet Gupta. I go with this designation of Product and Technology Solutions Architect, just a fancy name for I'm doing a development work at technology development work at C665. So the slide that you're currently seeing, this is just a screenshot or a card that I hold, which is called a FLO card. FLO is basically a blockchain which is similar to Bitcoin, which Rohit just mentioned. The major advantages of the FLO blockchain, which was previously known as Fluorine Coin, the major advantage that we find and that we leverage of this FLO blockchain is a feature that is called a flow data. So in flow data, what a FLO or Fluorine blockchain offers you is about 1024 bytes of plain text data that can be saved through every transaction. So none of the blockchains that we currently have, none of the blockchains allow you to actually save the data directly into a blockchain in plain text format. So what FLO allows you to do is, FLO allows you to about 1024 bytes of data can be stored directly into the blockchain in plain text. And that is a huge thing. You can make your own applications, you can make your own protocols, you can make your own logics, you can make your own smart contracts using this entire logic, entire feature that is available on the blockchain. Obviously, this data that is available, that is immutable, as Rohit mentioned in his speech about blockchain, any data that goes into the blockchain is immutable and cannot be changed. So as you can see in my flow card that you're seeing, there is obviously a spelling mistake in the architect word that has been put there by choice. Because I just wanted to show you that this particular thing, wherein I'll just open up my flow card and I'll just update it in front of you, and I'll try to update it again and show you that this can be done so quickly. So depending on the net speed that I'm getting, I'll just so this is the application that we have created. It is still in a beta phase, and this app's name is flowcard.app, and this is the web version of the app that we have. And if you just go to this particular website, there is a Google Play link as well, which has an Android app currently available, from where you can also create your same flow cards, and you can pretty much share with your friends and family this entire flow card. So this actually logs in with your LinkedIn data, because the app that we are creating, this is a social networking or a professional networking application that we are trying to leverage. So we have used LinkedIn data as its backbone, and we try to leverage its OAuth features. So I'll just log in with my LinkedIn credentials. I hope I have already logged in previously, so it will not ask me for the passwords again. So I'll just put those in. And I'll just sign in, and hopefully the card should get, the form should open up with my existing flow card data. And what I intend to show you is that I'll just update that small spelling mistake that I mentioned, and I'll just update that, and it will just again go back to the blockchain, and the card will just again come up.
So the standard pitch that we have for flow card is the fact that we were due for Dubai Blockchain Conference last year. And we had to go there, and this was the second time that we were going to the event, and we don't want to go there and just do the talk. So it took us exactly 30 minutes. So what we did, we actually ordered a pizza at Domino's, and we started building this app. And the pizza arrived, of course, sooner than app, but it was almost done. No, it take a little more time than that. It's just a pitch. So over to you, Abhijeet.
Yeah, so if you see the card that you were previously seeing, it had that spelling mistake in the architect word, and now I've fixed that, and it is already in the blockchain. So in this slide that you're seeing, this is the exact flow card or the visiting card that we have on the flow blockchain. And in this, if you see, this is a blue icon with the flow team, which is the icon for the flow blockchain. And what we have done is we have integrated it with the flow blockchain explorer. So let me just tell you what a flow blockchain explorer is. So every blockchain that you have, any transaction that you do, you need some way of knowing or some way of seeing those transactions. So a blockchain explorer is similar to what we have in form of a file explorer, or in terms of a browser, or any type of explorer allows you to actually explore through a data. So the blockchain explorer allows you to actually go through any transaction and see the details of a transaction. So the screen that you're currently seeing, this is the transactional data that I did just now in front of you using that particular FlowCard app. And the data that I just mentioned you, that this Flow blockchain can allow you to store about 1024, or I guess it has been upgraded to about 2040 bytes of data. That is exactly what you see on the screen. So I'll just highlight this entire text which has gone into the blockchain. So this highlighted text that you are currently seeing, this is a protocol version of the data. It obviously doesn't show you the exact data that is being shown on the on the visiting card, because we also keep in mind the privacy of the users, because the blockchain data is entirely public and we do not want the contact details, either email IDs or the phone numbers or anything to be available publicly. So what we have done is we have kept the entire information encrypted, and then we have the layer that actually decrypts it in real time and shows you the flow card data that you have over here. So if you look at this information, if it is, let me just try to zoom in it a bit. So if you I just will take one more minute to just show you one thing. If you just see this information is alphanumeric value with some hash value. So the hash characters that we have kept, what we have done is we have created our own protocol. So a protocol is basically an information that has a certain format, and that format is something that your application or your middle layer actually, sorry, oh, is it okay? Oh, sorry. So a protocol that we have devised our own custom protocols to actually read and write data into the Flow blockchain for our own application that we have created. So this hash values that you are currently seeing, this actually has an identifier, which is the flow card, which is the identifier for the application that we have created. The next entire data is the actual data that is available, and after that there are some more information that we have kept as part of that protocol information. So if you see in this, what we have done is we have actually leveraged a transaction, and if the bottom of the screen, if you see, there has been a transaction of 0.00001 flow. So anytime there is a transaction on a blockchain, there is a transaction or a transfer of value. So what does a basic blockchain transaction do? So say for example, I hold a few tokens of Flow blockchain, and you also hold a few, or may be holding zero Flow tokens. But you do have a wallet. So just like we carry our own physical wallets, currently we are also holding our YONO wallets or PhonePe wallets, Google Pay wallets, a lot of wallets that are being carried out to just transfer value of the currency that we actually transacted, which is INR. But when you do the transactions in blockchain, you actually do the transactions in form of a token that the blockchain actually is based on. So in Flow, the Flow blockchain, the token that we actually transact in value is called Flow. The token's name is also Flow. Similarly, in Bitcoin, the token's name is Bitcoin. In Ethereum, the blockchain, which is another form of blockchain, it actually uses the name of the blockchain is Ethereum, but the token that is being used, it's called Ether. So there are tokens that actually are being transferred whenever you make any transactions. So the token transfer is actually the value transfer that is happening between each and every transaction. So what is happening is that every time you do a transaction, the value transfers from one wallet account to another wallet account. But in between that transaction, you need to do something. Flow allows you to actually store data using that transaction. So what we are leveraging is, we are leveraging the Flow data capabilities, and the transactional value is not of importance to us. So if you see, the transaction value that has happened is very minuscule. It is about 0.0001 flow, and that is a very small amount of value that has been transferred. But the entire process's actual utility is not the transfer of value, but actually making that transactional data available in the blockchain, so that we can leverage that data into the blockchain and get that data into some application which you see over in this flow card. So just to set the premise, what we have done over here is we have created an application that is based on the Flow blockchain. So now, to create a similar application, what do you require? You require something, an application of your choice, your language of your preference. It can be Java, it could be C#, it could be Python, it could be anything. For us, since we are working on C# as our platform, what we started with is, we started with doing transactions on the blockchain, on the FLO blockchain. Then we figured out that for doing these transactions, we needed a layer which is called the Rpc layer of a blockchain, which is given by the blockchain wallet that you see on the screen. So every blockchain that you do, work with, that has a wallet similar to this. A wallet can be a physical or a desktop wallet that is available on your screen, which allows you to actually do those transactions. It allows you to create addresses for receiving flow or any sort of tokens. It allows you to send values to some other account, and it allows you to do any sort of transactions, view your balances, check all the transactions that are available. So I'll just go through the transaction screen, and I'll show you, it's sort of a passbook of a bank, which shows you all the transactions that have come into your account, that have gone from your account.
So Abhijeet, when Rohit was showing his link on the Ranchi Mall wallet, so most of us have created our addresses and posted in WhatsApp group. So one of those long-looking, ugly addresses were exactly these actually. So I mean, and so what Rohit showed us was also a piece of a wallet which has been customized very specific to the product ideas and the products that he's working on. So here what you have is a desktop-based wallet. So I mean, it is certainly not looking very nice. I mean, of course, it's one of those banking-looking softwares. But you also have fancy wallets like Google Pay and Paytm. You have something similar for blockchains as well. So Ranchi Mall wallet is very close to the Paytm wallet in terms of usability. So this wallet addresses that you generated right now, and let's say the promise that I have made someone who tweets maximum will get a flow on their address. So I'll be using one of these wallet to transfer that token flow so that you can actually see how exactly that transaction happens. So over to you, Abhijeet.
Yep, sure. Thank you, Abhijeet. So in this wallet, what I also want to show you is this progress bar that you're seeing at the bottom. So you see this green progress bar. I'm not sure if you are able to see this, but it says that it is synchronizing with the network. So what I usually do in comparing a blockchain to something that we already use is like a torrent network. How many of you have used torrent networks for downloading movies, games? Many. So in a torrent network, any computer science students here? Many? Yeah. So in a basic, in a network architecture that we do, there are two types of network architectures that are commonly present. One is a client-server architecture, and one is a peer-to-peer architecture. So in a client-server architecture, say for example, if you just want to download a file of a movie file or a games file or any file, what do? You just go to a specific HTTP address, you put in your URL of that file, and the file starts getting downloaded. Now what happens is, say for example, the server that you are trying to get the data from, that has a bandwidth capacity of say for example 100 Mbps, and you are having a computer with a 10 Mbps bandwidth. So in effect, you can only download the file in 10 Mbps capacity because the server allows you with a bandwidth that is more than 10 Mbps, so you can get the most of it. But say for example, you are not the only one who is downloading the file at that point of time, and there are about 10 people. So 10 people downloading that file at 10 Mbps is equal to 100 Mbps of the server's entire bandwidth being choked. So now the 11th person that comes in, he doesn't get any speed, or if the speed has been distributed, everyone's speed gets diminished. Okay, so that is what happens. So now comes BitTorrent or torrent layers. What happens is, you have a file, you share it on the torrent network, and your friend downloads it. You have 1 Mbps or 2 Mbps bandwidth, and your friend also has a 2 Mbps bandwidth. So your friend starts downloading it at a 2 Mbps speed. But now the third person comes into the network, and it doesn't have one server now, but it has two. Because you both are now servers acting in a peer-to-peer network. So the third person who comes in, he doesn't only have one choice but two choices. So now this entire thing actually multiplies. And there is a point of time where could be hundreds of computers who are actually downloading that exact file, but that is actually not downloading but actually syncing the file. So once that entire file is synced, that entire network gets synced with that exact file, and everyone has that exact version of that file. So the blockchain that you are currently seeing, this is similar to that. So the entire blockchain's data, it is in form of a distributed ledger. So that distributed ledger in some point of time must have existed in someone's computer. So now whenever one of the computers which is using this blockchain like mine, it is getting through the internet and downloading that blockchain's information and syncing the wallet, what it is doing is it is effectively downloading that entire ledger into my computer and it is syncing that exact thing into my computer as well. So now as many people are connecting to the network, as many number of distributed ledgers are getting created and as many number of synced true informations are being captured. So now any person who tries to leverage or tries to authenticate any transaction doesn't have to rely on just one source of information but has a choice of hundreds or maybe millions of servers. You get the point? Any questions in that?
Yeah, you can ask questions. Feel free to intervene.
I just wanted to make this analogy so that we have a common page to look into so that we just understand what's happening in the syncing of the blockchain network. Any questions?
Yeah, you can ask question.
You are saying there is a distributed ledger among all.
Correct.
So what about the privacy?
So the privacy is something, see, when you do a transaction on the blockchain, your transaction is public, but your identity is not public. Say for example, if you just see on this block explorer that I showed you, this doesn't show anywhere that the transaction was done by Abhijeet Gupta or it was done on behalf of 366 Pi. It doesn't say it anywhere. It just shows the public address that I have used to actually make those transactions.
And if it replicates?
If it replicates to him. If it replicates to all the nodes, the same information goes to each and every node. So the data that you are currently seeing on the screen, which is the flow data, you need to be aware what you are sharing as a flow data. So as I mentioned previously, the data that has been put on the flow data, it has been encrypted just for that purpose of the concern that you raised of privacy. So we are not putting anything on public network that can be seen by people because the transactions are public. We do not want people's private information to be shown in public. Yep. Sir, so let me just...
Abhijeet, you'll have to repeat sir's question because the rest of us couldn't hear
Yeah,
it.
so sir is asking that how does the syncing work and how does it ensure that someone doesn't have an older data and someone doesn't have a newer data? So let me just answer you in a quick way. So blockchain works, how does a blockchain work? So when I do a transaction, that transaction doesn't directly go to the blockchain. That just goes to the network. And as Rohit was mentioning about those servants, those are the miners. Okay, so in a blockchain infrastructure, there are nodes or there are servers which act as miners. So miners are what? They actually validate your transactions. So say for example, between 12.5 and 12.10, let's say 5 minutes is the time duration when 100 transactions have happened in a flow blockchain. The 100 transactions, out of those 100 transactions, 99 are found to be valid and one of the transactions is found to be invalid. Why that is invalid? Because the balance that has been used by the sender of the transaction is not a valid balance because his wallet was not synced. Say for example, you have a wallet which has 100 flow available right now, but you from some other wallet spent about 50, but you did not sync your current wallet that is available on your desktop. You come up to your desktop 10-15 days later, without syncing your wallet, which is still showing your balance as 100, you try to spend those 100 coins into some transaction. Yep. Correct? Yep. Right? No. Correct. So I was just coming to that. So whenever a transaction is done, that transaction is not a valid transaction. That transaction to become a part of blockchain, No, 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 no. No, no, no. So let me just again say, if you do a transaction, it can be a valid transaction from your wallet, but that may not be a valid transaction for the network. I was just coming to that. Say for example, you have an unsynced wallet of 100 flow available, and you try to spend those 100 flows from an unsynced wallet, and you try to spend those 100 transactions. That transaction would go to the network. But when the validations happen, the validators or the miners will find that this transaction has happened, but it is not a valid transaction because the balances that has been used, those are not valid balances, and it's an invalid balance. So that entire transaction would be left out of the blockchain, and the other transactions which are found to be valid, they will be put into the blockchain. So for example.
So put it into perspective, sir.
Yeah.
When we are used to banks and banking apps, so what we do is when we buy item from Flipkart, वो होता है ना जेब से पैसा चला गया तो चला गया, और वो आपके अकाउंट में जब पैसा होता है तभी आप खर्च कर पाते हैं, चाहे वो डेबिट कार्ड हो या क्रेडिट कार्ड हो. तो यहाँ पे कॉन्सेप्ट थोड़ा सा बैंकिंग सॉफ्टवेयर का जो लॉजिक है वो आपके हाथ में डाल दिया गया है. तो जस्ट बिकॉज लेट्स से एक तो अभिजीत सही कह रहे हैं, सो द मॉरल ऑफ द स्टोरी इज यू कैन नॉट स्पेंड इट बिकॉज दोज वैलिडेशंस आर पुट इन प्लेस. जी जी सर. जी that is correct.
Yes.
That is correct. तो क्या होना चाहिए सर? You are right. तो क्या होना चाहिए? नहीं सर, तो एग्जैक्टली तो वो जो कॉन्फ्लिक्ट है, तो कॉन्फ्लिक्ट रिजोल्यूशन का जो तरीका है वो ब्लॉकचेन में अलग अलग एलिमेंट पे देयर आर लॉट ऑफ एल्गोरिथम्स व्हिच रन्स एट ईच ऑफ दिस प्लेसेस. So I can discuss in detail in exact all scenarios that you want. Maybe soon after this conversation is over. हाँ, precisely. So and there are like hundreds of things. तो उसमें सर उसके लिए फिर मेरे को आपको बकायदा कॉपी किताब लेके भी बैठ के समझाऊंगा आपको. Give me some time. But the point is कि it is there. Or don't worry, it's safe. ठीक है.
And just to add to that, what sir was asking, the conflict resolution that is done actually, and the validations of the transactions are done by some sort of algorithms. So the algorithms of blockchains are basically categorized into these algorithms. So the algorithm that you have in Flow and Bitcoin, that is called a proof of work. So any type of blockchain which actually works on any blockchain that actually works on majorly 2 or 3 types of algorithms. One is a proof of work, one is a proof of stake, and one is a new one which is coming up, which is called a proof of authority. So these are some of the algorithms which actually do those conflict resolutions at real time by the miners, and then those transactions are actually put into a block, and that block is added into the blockchain and forms part of the actual blockchain, which is then synced into across every node that is available in the blockchain network. So that is something that happens. So just coming back to this, so when we started developing these applications, what we found out was doing these transactions through the wallet was easy, but creating our own custom applications was not easy. So as C# developers, what we try to do is, these wallets actually work on a basic layer which is called an Rpc layer, which is called a remote procedure calls, and those Rpc calls are basically designed into the blockchain wallet, and the blockchain wallet actually transfers those commands into the actual blockchain network and do those transactions. For us as software developers, we need some form of an interface to actually interact with these wallets or these daemons that are running over into some servers and then get these informations into the servers. So then we started developing our own software development kit, which is the FLO C# SDK, and that FLO C# SDK is something that is available on the GitHub. So that link and the URL is available on your screens. It's a GitHub repository
and
that
people who have registered, this link has been sent you over email, and if you're still able to download, and if you want to contribute to this project, please come
Please
forward.
feel free.
Yeah.
And currently we only have the C# version of this SDK ready. We invite Java developers, Python developers, and any language developers to actually come forward and replicate this on other languages so that we have a larger base of developers actually leveraging the FLO C#. The FLO SDK. Sorry? Okay. So if you just visit this particular link of GitHub, in the README what we have is the entire description of the C# SDK, what this repository contains and how to use it. So there is an entire series of YouTube videos that we have also created, which is available on our learning channel, which is called the SkyPiCast, and that is available on youtube.com/SkyPiCast. And there is a playlist with all the videos. It's about 12-13 hours of videos that we have created, and we have a hands-on session of the setup of the wallet, the setup of the C# SDK, what is the blockchain, the entire different types of algorithms that we were talking about, how to create an application, references, how to add those references, libraries into the applications, creation of applications running, everything is available in these YouTube videos that you can go through. So since it's a long series of videos, you can go to them at your leisure time and check out those. So it's the channel's name is SkyPiCast, YouTube's channel. We are just going through the FLO C# SDK that we have. The basic steps of getting along with this particular development is, what you need to do is you first need to download and install the FLO wallet. So the FLO wallet is something which I was just showing you in this particular screen. This is a wallet that the FLO blockchain actually gives you, and this is available to download from the URL, which is the official URL of FLO blockchain, which is flo.cash. So if you visit flo.cash, what you'll have is you will have the link to download the wallet and set up. It's a very easy download and setup platform. You just go through those next features of install sheet wizard, and you will have that in no time. What it will require is some amount of bandwidth of your internet and some amount of your time on the laptop to actually get that synced up. And once you have that synced up, then you can pretty much get ready with actually developing on the C# SDK. So next thing that you need to do is the second part, which is syncing of the FLO blockchain. Once that is done, which my wallet is currently doing, as you can see on my screen, it is still 7 weeks behind. The third thing is something that needs to be done on the configurational layer. So every blockchain wallet that you have, it has a configurational file which has a default extension called the conf file. So what we are going to see here is we are going to check the configuration file of FLO, which is called as a FLOConf. It has been renamed to FLOConf. It is in a Windows environment. It is available in the app data folder in your Windows environment. The shortcut to reach the app data folder is %appdata % in the run command. When you just open this app, there would be a folder called FLO, which is for the FLO, and you just open up this. You'll have this file called the flo.conf file. I'll just open up in a notepad editor and show you what the contents of this file are. So this is the flo.conf file, which has a few informations available in terms of configuration. I just want to mention one more thing. Any blockchain network, any blockchain that actually is running, it actually runs in several modes. One is the production mode, which is called the mainnet, which is the main network on which the actual transactions take place. There is another network which is simultaneously running, but it doesn't do any transactions related to the actual FLO currency or any currency that the blockchain actually offers. But that is called a testnet. So a testnet is an exact replica of the production network, but it is actually used for development purposes. And for any development related processes that you do, it is always advisable that you use the testnet. Because the currency or the coins that you are going to be spending, that are going to be the testnet coins, which don't actually cost anything, that are basically free. And there is also one of the networks which is available on most of the blockchains, which is called the reg test, which is for regression testing. So if you are doing a regression testing of your blockchain app, you can pretty much do the reg test net of the blockchain. So generally, in all of the blockchains, we usually have one testnet and one mainnet. So if you see over here in this configuration, what I have done is I have added the option of testnet equal to 1, which is making the testnet version of the network available in my computer. So this is something that I am currently doing. There are a bunch of
Abhijeet,
other...
So if we need to access these resources later, and how do we access them?
So this configurational file is entirely defined in the GitHub README that we have already provided. So in the meetup link and the emails that you have received, this URL for the GitHub is already there, and this entire configuration file that I just showed you, that is entirely available over here for you all to configure.
So people on WhatsApp were asking, please send links. Visit meetup.com/Ranchi blockchain. There is already a post which is made there, and if it is not, it will be made a post there. So you have all the links there. So you just have to go and join Ranchi blockchain. Meetup.com/Ranchi blockchain.
Yep.
Nothing's free.
So if you just go through the GitHub, I'll just show you the entire repository's directory structure for once. In this directory structure of the repository that you see, there are two folders. One is the FLO SDK, which is the actual DLL library or the SDK library's source code. And the second one is the FLO SDK test, which is actually leveraging the C# repository and creating a test application on a console application, and it is actually using that. So what I'm currently going to show you as well is a small WinForm application. It's a UI based application. What we will do is we'll create a small donation based app. So there is a community called JOCC, which is called Jharkhand Open Coffee Club, and it is an open community which helps startups in Ranchi. And what we have done is we have created a small application for them to receive donations. So any type of donations that they receive, we can pretty much capture those informations here, and the donations received is pretty much kept on blockchain. So that is the small application use case that we are creating over here to actually show you. So we have actually leveraged this C# SDK to create that. So let me just dive into that project application source code and just show you what is happening over there. So first I'll just run the application, show what it does, and then I'll just go through the source code once and show how to set up that entire SDK into your application. It's a very easy process, I'm telling you. So I'll just open this up. I hope the source codes are visible. If not, I'll just try to zoom in it a bit.
So, given that we have a logistics problem here, okay, we are also going to put this entire content on YouTube channel called SkyPiCast. So, where you have this source code along with this conversations and all of this. So, that's the reason we have Mohit giving a recording and helping us out here. So, don't worry, if you don't get to see all of this, you can come back to SkyPiCast later tonight or tomorrow morning and you can see all of this directly.
Yep, so I'll just start this application first, and then I'll show you what is happening in this application, and then this is, I must tell you, this is still on testnet because I don't want to spend my flows into this. So this application, there are few fields that I'm just filling up. It says the donation for, I'll just type in something for the test, which is workshop. The donation amount, let's just say 100 rupees. I'll just add in the donor name, I'll put in my name.
How many flow you are giving, Abhijeet?
Not flow, this is in rupees, it is just a receipt application.
That's not fair.
Yeah. Those are hard-earned flows, Abhijeet.
So you have to mine it. So how do you earn flow or how do you get that flow? So I mean, of course someone sends you or someone pays you. In India you cannot use your banking transaction, you don't have exchanges to do it. So just to put a disclaimer forward, we are not doing anything illegal here. And what we have is, this is all mined on a testnet. So what you do is you can run your own miners for testnet. They credit those flows to you for development purposes, and that's exactly what he's doing here.
All right. So once I have put in all these informations, what I'm going to do is I'm just click on submit, and at the back end what is happening is this entire transaction is going to the blockchain, and it just mentions that the donation has been saved successfully to Flow, and we have a link which says the C transaction on Block Explorer. So I'll just click on this, and if you remember I showed you that Block Explorer with that flow card data that I created. It will create a similar sort of an information, but for this demo purpose we have not encrypted the information, and then information is available publicly. So if you just open this transaction explorer, and if I just scroll down a bit on the page, what you can see over here in this particular section of the page here is that the first part says that the 365 donation app, which is the app identifier that I have used, Then it says that received with thanks from Abhijeet of Ranchi, amount of 100 for workshop and received by Amitesh. You have received it, Amitesh.
Thank you. Thank you. So 100 each will make me
Yeah, yeah. And if you see, this transaction was done from a particular address on the blockchain. And if you see, the transaction actually went to another address on the same testnet. So these addresses are important when you are doing these transactions. So as Rohit showed you in his wallet that he shared with every one of you, and I guess everyone has created that wallet as well. That wallet address that you have created, that is on the mainnet. The one that I am creating, this is on testnet. So the difference, how to distinguish between a FLO, a testnet and a mainnet address. So the addresses that you have generated, I'm pretty sure they start with the character F. And the one that I have created, if you see, these are all starting with a small O. So any testnet addresses that get generated on the FLO testnet, they actually start with this character. And the ones that you have created, they are the mainnet and they start with that particular flow. These are basically cipher algorithms that are in play and they generate those.
Abhijeet, I have a question.
Yep.
So if a user, if he creates a transaction,
Yep.
how is the data going inside the blockchain? You're using the FLO core node?
We are using a FLO core node that is currently running on my system,
Okay.
but that can be running on any server, that can be run on any remote instance.
Okay.
Usually the architectural layer is such that we try to keep the FLO wallet and the actual application separate. And we only whitelist the IP address of the application server into the FLO's Rpc configuration file so that the transactions that come into the FLO wallet only comes from a whitelisted IP.
And where is the private key of the application?
The private key of the application, currently whatever applications these are happening, these are application app side, these are not user-based transactions that we are doing. So the private keys are not something that we are doing. What we are doing is we are creating an application for the end users who want to use the FLO blockchain as a sort of a data store. So,
Yeah, but for your application private key,
yeah,
that is on the server.
on the server.
Thank
on
you,
the
sir.
server.
Yes, no,
Yep.
thanks.
Thank you. So I'll just show you what is happening behind the scenes on the source code. So what we have done over here is, I'll just close this up.
You have a last 20 minutes.
Yeah, sure. So I'm not sure if everyone is familiar with C# programming language and WinForms, but this is a small WinForm application that has been designed, which is very easy to create on a Visual Studio IDE, wherein you just open up a WinForm and you drag and drop controls into the page, and you pretty much have a working UI, and then you pretty much have events that actually trigger the code that you want to actually code. So what I've done is I've created these text boxes and a submit button. On click of this submit button, what I've created is the entire logic that actually gets data from those text boxes, creates it in the form that I want, and then puts it into the blockchain. But for that, what I need is, I first need to actually add the reference of the FLO C# reference library. For that, if you go to this GitHub repository, what you can also do is you can download this entire solution file and build this entire file and compile the DLL file on yourself as well. Or what you can do is you can go to the FLO SDK folder. Under this, go to the bin debug, and in this you have this FLO SDK.dll file, the PDB file, and there is a extra file which is required for all JSON conversion, which is called a Newton JSON.dll file. So these are the files that are basically required. So basically you can download these three files, add them as reference to your project and get things moving. Or if you want to compile the entire source code and get the latest version of this, you can pretty much download the entire repository, build the entire code and get these latest DLL files for yourself as well. So I have these already. So what I did is I added them to the reference by just clicking on the references, clicking on add reference, and then browsing the DLL files to whichever location I saved them to, and just click on OK. So once I had them, I pretty much had those references available over here. So in the FLO SDK C# DLL that we have all the Rpc connector methods which are defined. So if you want to check what are the Rpc connectors that are available or the Rpc methods that are available, Once you have the wallet up and running, you just go to the help, go to debug, and in that there is a tab called console, and in here you just type in help. In help, if you just type in help and press enter, you have a list of all the commands that are available for actually communicating with the blockchain. So what we have done is we have actually implemented all these commands into our SDK, and these all are available without actually integrating directly with the wallet, but actually that entire layer of SDK allows you to actually perform all these transactions, all these function calls. So for this, what we need to do is, we first need the username. If you remember, we had a RPC configurational called the username and a password. So for interacting with the wallet, you need an RPC username and password through which you can actually do the transactions. So these RPC username and passwords are required. You need a wallet URL. So if the wallet is running on your own computer from where your application is running, it is usually the local host or your own computer's IP address. If it is running on some other node in a network that you can access, the wallet URL will be the IP address for that particular computer. Usually the wallet port for FLO blockchain is 7313 on the testnet and the mainnet as well. So these are some of the information that are required. Once you have that, we require our SDK to be actually initialized. So for that initialization, what we do is we create an object of our RPC method class, and we just pass in the username, password, wallet URL, and the wallet port. And these are all that are required to actually initialize the entire SDK class object. And once we have this, we pretty much have access to all the functions, and we are pretty much connected to the blockchain from our application. So what I have done in my application is, I have just accepted all the informations from the application which were available in the text boxes. For example, the donation for, the donation amount, the donor name, the location or the address, and the received by. So these are all accepted in these string variables. And then I'm just creating that flow data text. So this flow data text is nothing but a basic string variable, and I'm just creating this by concatenating information as I saw fit for my application. So that is a very basic form of just creating a small string variable that you want to just put on blockchain. Then what you need to do is, you just need to call up your object, the RPC object, and you just call in one of the basic methods of sending your transaction to the blockchain, which is called send to address. So for this send to address, what I have done is, you need to send a transaction to some address. So if you remember, we need some address to actually do the transactions. So what I have done is, I have just configured one address to receive all the transactions. And that transaction address has been put up over here, hard-coded. This can be dynamically done, this can be accepted from the user, it can be done any way that you see fit. So what we have done is, we have just created this donation address from where all these receipts will be kept. So this send to address function, what it does is, it just requires you to send the address which you are sending the transaction to. What is the amount of flow that you are transacting? So currently I am doing just 0.1 flow, just because I am doing it in testnet. I am just doing it 0.1. You can do it in higher quantities, you can do it in even smaller quantities. Then what you need to do is, you just need to send in the transactions identifiers which have been put in as 3665 donation app. So if you just move your mouse over the send to address, it actually shows you all the basic parameters that need to be sent. So basically the parameters are address, the amount, the comments to whatever fees that need to be subtracted. Sorry? In terms of decimal, when you do it in C#, you need to send it as 0.1 M. So in terms of when you do a transaction in decimals, you do that M thing in C#. That is just, sorry? In C#, that is a standard of C# language. That's not a standard of our SDK. That is a standard of C#. So whenever you initialize a variable with a decimal value, that decimal value has to have that M. Typecasting. And these are pretty much some of the parameters that are required. So there is a concept of transaction fee as well in any transaction that you do on blockchain. So for example, when we say that we transact one flow to someone, that transaction of one flow to from one address to another address happens. But that transaction also has a fee that needs to go to the network, because the people who are actually validating that transaction, they also need some incentive. So that transaction fee is something that needs to be paid by either the sender or the receiver. So if the transaction fee is to be has to be borne by the sender, then this subtract fee from amount has to be set to false. That means the entire amount that I am sending, that goes to the receiver, and the extra amount of transaction fee has to be borne by the sender. That gets deducted extra. But if you want the receiver to bear that, what you do is you set the subtract fee from amount to true. And what then happens is, if you are sending one flow, the receiver doesn't actually receive one flow, but it receives a deducted amount of the transaction fee as well. Okay? So these are some of the values that need to be set. So what I've done is I've just set up all these values, and at the last what you see is the flow data variable. So that flow data is the actual text data that needs to be set. So once you have this command run, that transaction has gotten into the blockchain, and the value that comes from blockchain is in form of a JSON object. So what I've done is I've used a library called Newtonsoft JSON, which is an open source library, and I've leveraged that library to actually parse that entire JSON into an object and create that object response object. So once you have that object, we just check one of the parameters, which is called error. So if there is any transactional error, you will have a parameter of the response which calls error, and if that error parameter is present in the response, that means that your transaction has met some error and it has not been successful. And what we do in that case is we just check that what the error message is, and we show it to the user. But if that error is not available, we pretty much check one other parameter which is called a result, which actually shows you the transaction ID and everything, and that actually gets you to that blockchain explorer. So this is something that we can pretty much do. So if there are any questions from any present C# developers who have any queries regarding how to do this, please feel free. Any questions regarding this? I'm pretty sure this is some, yep, sure. This is. So the application that you saw, that flow card application, that is a web application. The architecture for that application is a bit different. The transactions that are done, they are done at an API level. The API is a web API that is developed on C# and that is hosted on a web server. And the application that you saw, the UI, that is on a different server that interacts with that API and then gets things done. This is a Windows application that I'm currently showing. Yep. But as I mentioned, this entire thing is done on C#, which means it's a Windows only thing. So we request any Java developers, Python developers to actually come forward and extend this library to actually get it into Python or Java so that more people can actually adopt this. We are also trying it on our front as well, but we are actually not finding time to do that. And we also need to make the documentation a bit better as well. But I think the developers who are going to be doing this, they can pretty much figure it out. And we also have that YouTube link, which is pretty exhaustive, wherein all these things that I just showed you in pretty quick time, that has been mentioned very detailed over there. So that's it pretty much from my side.